All right, so we are going to look a little bit more specifically at the limits of exponential functions. And then on the next lesson, which would be next week, is going to start looking at the limits of trig functions. So with exponential functions, remember that they have that horizontal asymptote. So that is going to play a part in our limits. We're going to look at this one real quick. So we have f of x is equal to 2/3 raised to the x minus 1 minus 2. So the limit as x approaches negative infinity, so as it approaches, as the graph moves basically to the left, our graph or our y values are going to reach positive infinity. But then as we reach positive infinity, then you can see that it's going to start tapering off there at -2. Remember, that is a horizontal asymptote, so therefore it would get really close to it, but never touch it. The next example, we have f of x is equal to 3/2 raised to the x plus 2, and then minus 2. So the limit as x approaches negative infinity, as we move to the left, you can see that it is approaching -2 at the bottom. So never touches that. That's that horizontal asymptote. And then as x approaches positive infinity, moving to the right, it's going to reach, it's going to continue on and on to infinity. And then we have f of x is equal to -1/2 x plus 1 minus 1. So the limit as x approaches negative infinity, moving to the left, our y values are going to reach negative and infinity as well. And then as the graph moves to the right, it's going to get really, really close to that horizontal asymptote, which is at -1. And then f of x is equal to -1/2 raised to the negative x plus 3 plus 2. So for this one, as x approaches negative infinity, as it moves to the left, it is approaching that horizontal asymptote of +2. And as x is moving to the right, it is positive infinity. It's going to reach negative infinity as well. So based on this information, you can see that as x approaches negative infinity or positive infinity for exponential functions, you have 3 possible outcomes. So you either have positive infinity or negative infinity or the value of that horizontal asymptote. And then by studying and looking at those graphs, you can remind yourself the 4 rules determining if a function will be growth or decay. Okay, so we can tell, is it going to be shooting upwards or is it going to be approaching that horizontal asymptote? So for growth, we're going to have b is greater than 1. And there are 0 or 2 reflections. So 0 reflections would mean that the entire thing is not negative or that both the number and the exponent are negative. So that would be 0 or 2 reflections. So they would both it'd be reflected over the x-axis and the y-axis. When looking at b as well, if it is between 0 and 1, that's going to be a decay, and there are 0 or 2 reflections. All right, so for growth now, there would be between 0 and, if b is between 0 and 1, and there is 1 reflection. And then again, looking at decay at b as well, if b is greater than 1, it's going to be decay, and there has to be 1 reflection to go there. So this just helps you get an idea of what these graphs are going to look like. Is it going to be a growth or is it going to be a decay there? All right, so the limit as x approaches positive infinity, so of 2/3, so that's our b, it's between 0 and 1, of negative x minus 1, and then minus 2. So this would be that our b is between 0 and 1, and we have 1 reflection because x is negative. Okay, so that's our 1 reflection. So it is going to look like this. This is negative 2. It's going to be a growth there. Okay, so our graph there is going to be growth. So as x approaches positive infinity, it's going to, our y values are going to approach positive infinity as well. Okay, so the limit as x approaches negative infinity of negative 0.4x minus 4. So therefore on this one, as we reach negative infinity, we have b is between 0 and 1, and we have 1 reflection because the whole function is negative with that negative out front. So our graph is going to look like this. Our horizontal asymptote is there at negative 4. So as x approaches negative infinity, then our graph is going to approach negative infinity as well. Okay. As x approaches positive infinity, of negative 2/3 raised to the negative 2, negative x plus 2 plus 3. So this is b is between 0 and 1. So this is going to be, and there are 2 reflections because we have a negative 2/3 and a negative x. So there's those 2. So that's going to be a decay. So we are going to, your graph is going to look like this. This is going to be 3. It's going to look like this. And so as x approaches positive infinity, it's going to, our y values are going to approach negative infinity. So b is between 0 and 1 here, and there's 2 reflections, so that's going to be a decay. All right. Okay, so we have the limit as x approaches infinity of negative 2 raised to the negative x minus 1 plus 2. So this time we're going to, so I'm just going to go ahead and note these out here. B is larger than 1, and there are 2 reflections. So therefore, that's going to be growth. So I know it's going to look like this. Okay. So on this one, as x approaches positive infinity, moving to the right, our limit is going to approach that horizontal asymptote, which I know what that is based on this information right here, so this is going to be, it's going to approach 2. All right, so example 5 here, we have the limit as x approaches negative infinity of e raised to the negative x minus 1 plus 2. So for this one, we are going to have, b is greater than 1, and there's 1 reflection because there's 1 negative sign right there. Then minus 1 is what shifts it right or left, and then the plus 2 shifts it up or down. So my graph here is going to look like this. And it's going to approach right here at 2. So as x approaches negative infinity, it's going to approach, our y values are going to approach positive infinity. The limit as x approaches positive infinity of negative 0.4 raised to the x minus 4, this is going to be, b is between 0 and 1, and I have 1 reflection. So this is going to be a growth. All right, and so this is at negative 4. So as x approaches positive infinity, moving out to the right, our limit is going to, or y values are going to approach that horizontal asymptote. Okay, and then we have the limit as x approaches 3 of e raised to the 2 minus x plus 2. So this one is kind of tricky because they decided to write the x second. So, but here we still have b is greater than 1, and we have 1 reflection. Okay, for example 3 here, we have the limit as x approaches 3 times e to the 2 minus x plus 2. Now, this one's kind of tricky here because we kind of slid this one in here without kind of making a big note about it. So this one, if you'll notice, is x is not approaching infinity here. Okay, so pay close attention to that because you can kind of get in the habit, I guess, of just doing this over and over and over repetitively. So as x approaches 3, so remember, I can just probably use substitution as long as there's not any kind of asymptote or does not, or undefined, I guess, at this 3, which it's not. So I'm going to just go ahead and replace 3 in for x. So this is going to be the same thing as e raised to the 2 minus 3 plus 2. So this is e to the negative 1 plus 2, which is 1 over e plus 2e over e. So what I did there is I tried to make sure that I had the same denominator. So I multiplied this by e over e. Okay, so therefore I have the same denominator, and I'd have 1 plus 2e over e. Again, here trying to be kind of tricky because this is not approaching positive infinity or negative infinity. It's just approaching a number. So it's negative. It's approaching negative 2. The limit as x approaches negative 2 of 1/2 raised to negative x plus minus 3 plus 3. So I can just go ahead, as long as this value, as long as my function is defined at this number, remember, I can just use substitution. So I'm going to have 1/2 raised to the negative 2 minus 3 and then plus 3. So this is going to be 1/2 raised to the negative 1 plus 3. When I take something to the negative 1 power, it makes it flip essentially. So this is going to basically be 2 over 1, or just 2 plus 3, which is 5. Okay, so I would say for this one, the trickiest part, I guess the part that you're going to have to recall is, what do these exponential functions look like? What does it look like whenever I reflect over the y-axis? What does it look like when I reflect over the x-axis? And as these approach positive infinity, are they approaching positive infinity, negative infinity, or that horizontal asymptote? And then make sure you're paying really close attention that we're not trying to be sneaky and get one past you as far as it's approaching a certain number. So pay close attention to what your x is approaching, because it's really easy to kind of get in the pattern of this, certain way. So more than likely, you're going to be able to plug in an x value because there's no restrictions on the x domain for exponential functions. There's a restriction on the range, but not on the domain. So that's going to be defined all the way through. It's continuous all the way through. So you'll be able just to substitute in that number and then just simplify from there. And that's it.